Hello my dear students, welcome you back again. In previous video lecture we have started unit number 4 and this is the second video lecture on unit number 4 and we are going to discuss 4.2. 4.2 types of different CPU scheduling algorithm, in which we can discuss first algorithm, very simple algorithm, first come first serve CPU scheduling algorithm. The outcomes of today's video lectures are, after watching this video, students are able to explain what is the need of CPU scheduling, what are the different criteria of CPU scheduling. Then students are able to explain first come first serve, that is FCFS scheduling, and its advantages, disadvantages, and they can easily calculate the average waiting time of a given problem. So it is basically our focus is on first come first serve scheduling algorithm. Before going to start 4.2, we must revise the basic concepts in 4.1. So what is the CPU scheduling? So proper definition of CPU scheduling: it is a process which allows one process to use the CPU while execution of another process is on hold, because that process is waiting for IO operations. Meanwhile, a second process which is in the ready queue is allocated to CPU. That process is called as CPU scheduling. Generally, CPU scheduling is used to make system efficient, faster and fair. There are basically two types of CPU scheduling: non-preemptive and preemptive. In non-preemptive, once a process is allocated to CPU, then CPU will be released after completion of that process or when process is terminated. Okay, that type of scheduling is called as a non-preemptive. In preemptive scheduling, if current process which is in the execution, which having the CPU allocation, is suspended, if highly prioritized process comes, then current process will be suspended and highly prioritized process allocates a CPU. That type of scheduling is called as preemptive scheduling. So these are the 5 basic criteria for CPU scheduling. First, CPU utilization means your CPU must be continuously busy, it cannot be idle, so it must be a maximum. Throughput, a number of processes executed by a CPU per unit time, so it is the outcome, so it must be high. Then turnaround time. Turnaround time is amount of the time to execute a particular process. So it is nothing but it is the addition of waiting time plus a burst time of that process. Then next, waiting time. The amount of time that process has spent into the ready queue is known as waiting time. Okay. Last, a response time. The amount of time the process taken from when its request is submitted to the CPU allocation and first response is produced. So that is the difference between a time period when process requested a CPU first and it gets a response of that CPU. So that is the time period is called as a response time, first response time. Okay, so these are the criteria of CPU scheduling. So CPU utilization must be high, throughput must be maximum, turnaround time, waiting time and response time must be minimum for very efficient system. Before going to start a scheduling algorithm, we must focus on this different timings of processes. Okay, So process is nothing but a part of the program which is in the execution, or it is a job which is ready for execution. Okay, so before going to study, we must clear these concepts and its definition, because this definition can be asked for 2 marks in MSBT question paper. Okay, so these concepts are arrival time, waiting time, response time, burst time, completion time, and turnaround time. So arrival time is nothing but a time, the point of time at which a process entered into the ready queue. A time slot or time period or time point at which a process enters into the ready queue, that time is called as a arrival time, when it is arrived in the ready queue. Okay, so that is called as arrival time. Then waiting time. The waiting time is amount of time spent by the process waiting in the ready queue to get a CPU. Okay, so that is the total time spent by the process in the ready queue. It's known as waiting time. The formula for waiting time is very important. Waiting time is equal to turnaround time minus burst time. Okay, so my dear students, we can explain this when we can have the definition about turnaround time and burst time. The next, response time. A response time is amount of the time after which a process get a CPU from the first time it get entered in the ready queue. So it is a first response get by that process after it requested a CPU. So response time is equal to the time at which a process get first response from CPU minus arrival time. Okay, so that is a response time, after which time slot it get the first response is called as a response time. Then fourth time, burst time. Burst time is nothing but amount of time required by the process for execution on the CPU. So that is the total time required by the process to get executed from the CPU. So that is the period of time that process will utilize a CPU. So it is also called as the execution time. It may also called as a running time. So that much amount of the time that process will use a CPU. Okay, so that is a burst time. Okay, so it's a burst time. Next, completion time. A completion time is a point of time at which a process completes its execution on the CPU and take exit from the system. So that is a point of the time at which a process exit from the system is called as a completion time. It also called as a exit time. Last, sixth time, that is a turnaround time. A turnaround time is a total time spent by the process in the system. So total time is nothing but a waiting time plus a burst time. So how much time it spent into the ready queue and how much time it requires to complete a execution. So it is the addition of waiting time plus burst time. So we can easily calculate a waiting time using this formula. So waiting time is nothing but turnaround time minus burst time, or we can say that turnaround time is equal to waiting time plus burst time. So my dear students, these definitions are very important. These formulas are also very important, because in this 4.2 we have 6 different algorithms of CPU scheduling, its working, its advantages, its disadvantages. Also we are going to calculate average waiting time of individual process. Average waiting time, that is a total waiting time divided by number of processes in the given problem. So that is the average waiting time. Okay, before going to start the algorithm, we must revise these concepts once again. So turnaround time is nothing but waiting time, that is the exit time, total time it requires for the exit minus arrival time. Okay, or waiting time is equal to turnaround time minus burst time. So we must have a third formula here, the average waiting time. Average waiting time is equal to sum of waiting times of all processes divided by number of processes in given problem. Okay, so average waiting time is equal to sum of waiting times of all processes divided by number of processes. So while we are going to solve this average waiting time problems using the algorithm, we required a Gantt chart. Okay, so Gantt chart is a horizontal bar chart showing a starting and ending of each process in the CPU. So it is a graphical representation of CPU utilization using horizontal bar is known as Gantt chart. So we must draw a Gantt chart to solve an average waiting time problem. So in this chapter, in this unit 4.2, we are going to discuss 6 popular algorithms in the CPU scheduling. The first one is first come first serve, that is FCFS. Second is shortest job first. Okay, so shortest job first, SJF algorithm. It has another variant, shortest job next also. Then priority scheduling. Then shortest remaining time first algorithm. Very famous algorithm, round robin algorithm. Last, multi-level queue scheduling algorithm. Okay, so these are the 6 algorithms we are going to discuss. Okay, so there will be minimum 2 to 3 questions on these algorithms. It may have 2 problems to solve average waiting time using any method. Okay, so in this video lecture we are going to discuss first come first serve scheduling. Once we get the structure, how to solve the problem, how to explain the algorithm, that same structure can be implemented to remaining algorithms. Okay, before going to start the first come first serve reflection spot. Okay, listen the question carefully. What is a Gantt chart in the CPU scheduling? Stop this video, write down your answer, take your time. Okay, if you have completed your writing answer, so Gantt chart is nothing but it is a graphical representation of CPU utilization using horizontal bar. Okay, so using the Gantt chart we can easily find out the average waiting time. So we must have a 3 definition in our mind. Turnaround time is equal to exit time minus arrival time. Waiting time is equal to turnaround time minus burst time. And third, average waiting time is sum of waiting times of all processes divided by number of processes in given problem. So these are the 3 important formulas. Now we can start our first algorithm. As the name suggests, first come first serve scheduling. First come first serve means a process which enters in the ready queue first or which arrives in the ready queue first gets the executed first, or it will assign CPU first. So that algorithm is known as first come first serve. In very simple words, the process which enters into ready queue first will get the CPU first. Okay, so that is the first come first serve. It is similar to first in first out scheduling in data structure. Okay, first come first serve scheduling is generally used in batch operating system. Okay, so in this scheduling there will be a ready queue in which new processes are entered from the tail and CPU will be allocating from the head. Okay, so it is similar to a real life example of buying a cinema ticket at the counter. The characteristics of first come first serve scheduling. It is very important characteristics. First is it is a non-preemptive scheduling. Non-preemptive means once a process is allocated to CPU, a CPU will be released after the completion of that process, or when that process is terminated successfully, exit system call will occur, then and then CPU will be released. So that is a non-preemptive. The job which comes first in the queue will get the first response. It is very easy to implement and understand. Overall performance of this algorithm is very poor because average waiting time in this algorithm is very high. So up till now we have seen the features, characteristics and definition of that algorithm. When you have a question in MSBT question paper, explain the FCFS, then you must define that algorithm, then you must list out at least 4 features of that algorithm, then define turnaround time, waiting time and average waiting time definition. Okay, then take one example. Okay, with the proper example you can explain the algorithm very easily. So in this condition we have a processes, number of processes waiting for a CPU utilization. It's burst time. Burst time, it is a time required by that process to complete a task from the CPU. So in the problems there is no unit given, so we can consider it as a milliseconds, ms. Okay, if a time given in the milliseconds, so you can take a unit as a milliseconds, or you can take a unit as a unit seconds. Okay, so I am taking as a milliseconds. Okay, then arrival time. Okay, so arrival time is a time point of the time where your process enters into the ready queue. Okay, for this purpose we have a 3-column problem. Okay, so these are the processes, these are the process names. Burst time, burst time म्हणजे जेवढा वेळ त्या प्रोसेसला लागणार आहे एक्झिक्युशनसाठी ती वेळ, म्हणजे त्याला 6 मिनिटं लागणार आहेत P1 ला एक्झिक्युशन पूर्ण करायला, P2 ला 3 मिनिटं लागणार आहेत, 3 मिलीसेकंड लागणार आहेत, P3 ला 8 मिलीसेकंड लागणार आहे CPU, P4 ला 3 मिलीसेकंड लागणार आहे आणि P5 ला 4 मिलीसेकंड CPU लागणार आहे. ओके, आणि ह्या प्रोसेसेस रेडी क्यू मध्ये कशा आलेले आहेत, तर पहिली कोण आलेली आहे, P4 आलेली आहे. ओके, तो पहिला अरायवल कोणाचा आहे, P4 चा, म्हणजे ह्याचा पहिला नंबर लागणार आहे. त्यानंतर दुसरं कोण आला आहे, दुसरा आला आहे P1, ह्याचा दुसरा नंबर आहे. त्यानंतर तिसरा कोण आहे, तर तिसरा P5 आहे, तर हा तिसऱ्यांदा त्याला एक्झिक्युशनला चान्स मिळेल. चौथा कोण आहे, तर ओके मी थोडंफार चुकलेलं आहे. पहिलं कोण आला, तर पहिला आला तुमचा P4 आला. त्यानंतर कोण आला, त्यानंतर आला 2 नंबरला P3. ओके, 3 नंबरला P1. ओके, 4 नंबरला कोण आलेला आहे, 4 नंबरला आलेला आहे P5. आणि सगळ्यात शेवटी कोणाला एक्झिक्युशनला मिळणार आहे, तर सगळ्यात शेवटी मिळणार आहे एक्झिक्युशनला P2 ला. ओके, तर ह्यांच्या अरायवलनुसार ह्यांचा सिक्वेन्स कसा होणार आहे, तर पहिल्यांदा कोण आला बघा, पहिल्यांदा आला P4, म्हणजे P4 पहिल्यांदा एक्झिक्युशनला जाईल. त्यानंतर परत कोण आला आहे, P3 आलेला आहे, कारण त्याचा अरायवल टाइम 1 आहे. त्यानंतर कोण आलेला आहे, P1 आहे, P1 आला कारण की त्याचा अरायवल टाइम 2 आहे. आता इथं 3 नाही, तर अरायवल टाइम 4 कोणाचा आहे, तर P5 चा, म्हणजे P5 एक्झिक्युशनला जाईल. आणि सगळ्यात शेवटी कोण आलेला आहे, तर P2 आलेला आहे. ओके, तर ह्याचा अर्थ काय आहे की क्यू मध्ये हे सगळे अरायवल टाइमनुसार आलेले आहेत. P4 पहिल्यांदा आला, P3 आला, P1 आला, P5 आला आणि P2 आला. तर पहिल्यांदा एक्झिक्युशनला कोण जाईल तर P4 जाईल. त्याला वेटिंग करावं लागेल का नाही, कारण तो 0 मिलीसेकंद आलेला आहे आणि डायरेक्टली त्याला CPU अलोकेट होईल. तर P4 किती वेळ CPU युटिलाइज करेल तर तो 3 मिलीसेकंद CPU युटिलाइज करेल, कारण की त्याचा बर्स्ट टाइम 3 मिलीसेकंद आहे. ओके बरोबर ना. तर तो 3 मिलीसेकंद ते यूज करेल. 3 मिलीसेकंद नंतर पुढची प्रोसेस कुठली येईल P4 टर्मिनेट होईल. पुढची प्रोसेस येईल P3. ओके तो किती वेळ यूज करेल तर तो 8 मिलीसेकंद यूज करेल. म्हणजे 3 आणि 8 11 मिलीसेकंद नंतर पुढची प्रोसेस कुठली येणार आहे P1. P1 किती वेळ यूज करेल 16 मिलीसेकंद 6 मिलीसेकंद म्हणजे 11 प्लस 6 17 मिलीसेकंद नंतर कुठली प्रोसेस चालू होणार आहे P5 तो किती वेळ यूज करेल 17 प्लस 4 21 मिलीसेकंदला सगळ्यात शेवटची प्रोसेस येईल P1 आणि तो किती वेळ यूज करेल तर तो 3 मिनिटं म्हणजे 24 मिलीसेकंदला तुमचं पूर्ण दिलेला प्रॉब्लेम हा टर्मिनेट होईल. तर आपण पहिल्यांदा काय करायचं ह्याची बेरीज करून घ्या. ओके 6 3 9 9 8 17 17 3 20 आणि 24 म्हणजे ही सगळा जॉब पूर्णपणे एक्झिक्यूट होण्यासाठी P1 to P5 टोटल वेळ CPU युटिलायझेशन किती लागणार आहे तर 24 मिलीसेकंद लागणार आहे. तर गँग चार्टमध्ये स्टार्टिंग 0 असेल तुमचा आणि एंडिंग 24 बरोबर ना. तर तुमचा गँग चार्ट बरोबर आहे असं कन्सिडर करू, कारण की गँग चार्ट विल बी रिप्रेझेंट टोटल टाइम रिक्वायर्ड टू कंप्लीट अ गिवन प्रॉब्लेम. ओके तर हे तर सिंपल कळलेलं आहे. ओके तर आपण परत एकदा हे रिवाइज करू. तर पहिल्यांदा कोण आला P4 आला करेक्ट. त्यानंतर कोण आला P3 आला. त्यानंतर कोण आला P1 आला. त्यानंतर बरोबर ना P1 P5 P2. ओके तर हा गँग चार्ट आहे. ओके सो using the problem we have draw the gang chart because depending upon the arrival it has a priority first, then it has a second, it has a third, it has a fourth, and last one this comes at the last. Okay so I have prepared a gang chart starting from the 0 arrival time. Process come first which get the allocation of the CPU P4 utilize how many milliseconds so 3 milliseconds. So 0 to 3 is utilized by P4. Okay very easy. After the 3 milliseconds and next comes who is next, so next is the P3 will assign the CPU. It utilize 3 plus 8 11, so 3 to 11 P3 is in the CPU. Okay so it is a 8. It is a burst time of P3. Yes, after the complete execution of P3 which process comes next, so already 0 first is arrived, second is arrived, now third is P1. So P1 requires how much time of CPU 6, so 11 plus 6, so from 11 to 17 P1 is in the execution, so it is a 6 milliseconds. Yes, it is 6 milliseconds. Now which process comes next after the P1 is completed, now it is chance of P5 will start at the 17 milliseconds and will take a CPU for 4 milliseconds. So 17 plus 4 21. Okay so 21 and 21 plus a 3, 21 plus 3, so 21 plus 3 24. Okay it must be 24 so there will be mistake in the reference also, so it must have 24 at the end. So 21 to 24 it will be P2, so that period 17 to 21 4 and it is a 3. Okay so this is a gang chart which show the process start. Okay so it is your response time when it is started, so at the 0 time cycle, so it is a CPU time. At the 0 P4 will come, it remains for 3 milliseconds. After the 3 milliseconds next process which comes first is P3. It will utilize for 8 milliseconds, so it is in the CPU for 11 millisecond. After the 11 millisecond, next process P1 will come. It will take a CPU for 6 milliseconds. So at the 17 millisecond, P1 will be terminated, and next process P5 will be taken for the execution. It requires a 4 milliseconds, so it utilizes a 4 millisecond because it is non-preemptive. So 17 plus 4, at the 21 millisecond, P2 will get executed. Okay, so this is your Gantt chart. Now we want to calculate a waiting time of individual process. So my dear student, so it is your turnaround time. So turnaround time, so what is the formula of waiting time? Waiting time is equal to turnaround time minus arrival time. Okay, so how to calculate a waiting time of the process? For first we are calculating for P4. For P4, a turnaround time, starting time is 0, okay, and its arrival time is also 0. So it is a 0 minus 0 is equal to 0. Okay, it is quite easy. Gantt chart वरून फाइंड आउट करणं फार सोपं आहे. P4 कधी चालू आला? 0 ला. तो आला कधी? 0 ला. सो 0 minus 0 is a 0. So waiting time of P4 is 0. आता पुढची प्रोसेस P3 चा वेटिंग टाइम करण्यासाठी P3 चालू कधी झाला? P3 चालू झाला 3 मिलीसेकंडला, आणि त्याचा अरायवल टाइम काय आहे? मायनस त्याचा अरायवल टाइम. P3 आला कधी? अरायवल टाइम 1. तर त्याने किती वेळ वाट बघितली इन रेडी क्यू? 2 मिलीसेकंड्स. ओके, व्हेरी इझी. देन P1 चा वेटिंग टाइम काढायचा आहे आपल्याला. P1 इज इक्वल टू P1 चा टर्न अराउंड टाइम म्हणजे तो कधी चालू झाला? 11 मिलीसेकंडला, मायनस P1 रेडी क्यू मध्ये कधी आला? तर 2 मिलीसेकंडला. तर 11 मायनस 2 म्हणजे 9. ओके, आता आपण पुढच्या प्रोसेसचं काढायचं आहे P5चं. P5चं वेटिंग टाइम काढण्यासाठी P5 कधी चालू झाला? तर 17, बरोबर ना? तर 17 मिलीसेकंडला तो चालू झालेला आहे, पण तो अरायवल टाइम त्याचा काय आहे? 17 मायनस अरायवल किती आहे? अरायवल त्याचा 4 आहे. 17 मायनस 4 म्हणजे तो टोटल किती वेळ वाट बघतोय? 13 मिलीसेकंड. ओके, आणि लास्ट P2 सगळ्या शेवटी आलेला आहे, त्यामुळे त्याचा वेटिंग टाइम जास्त असणार आहे. तर P2 स्टार्ट कधी झाला? 21 मिलीसेकंडला, आणि तो आलाय कधी? अरायवल काय आहे P2चं? तर तो 5 मिलीसेकंडच्या वेळी आलाय, कारण की तो पूर्वी 0 to 4 मिलीसेकंडमध्ये नाहीच. ओके, तर 21 मायनस 5 म्हणजे 16, बरोबर ना? तर हे झालं इंडिव्हिज्युअल वेटिंग टाइम. जर आपण ह्यांचं सम केली तर टोटल सम किती येते बघा? ॲव्हरेज वेटिंग टाइम किती आला बघा? म्हणजे सम ऑफ ऑल द वेटिंग टाइम्स 11 प्लस 13, 11 प्लस 13 इज नथिंग बट 24, 20 प्लस 24 प्लस 16 40. तर टोटल सम ऑफ वेटिंग टाइम आला 40, आणि ॲव्हरेज वेटिंग काय टाइम काढायचा असेल तर सम ऑफ ऑल द वेटिंग टाइम मायनस नंबर ऑफ प्रोसेस. नंबर ऑफ प्रोसेस किती आहेत? 1 2 3 4 5, म्हणजे 40 भागिले 5 म्हणजे 8 मिलीसेकंड हा ॲव्हरेज वेटिंग टाइम आहे प्रत्येक प्रोसेसचा. ओके, सो इट कॅन बी लाईक दिस. सो P4, so turnaround time 0, arrival time 0 0. P3 3 minus 1 2, yes. P1 will start 11, arrival 2 9. P5 17 minus 4 13. P2 start from 11 millisecond, arrival 5, so 16. So addition of all is 14 divided by number of processes 4. So average waiting time of this algorithm is 8 millisecond. So it is very easy to calculate using the Gantt chart. When you prepare the Gantt chart, you can have easy answers. My dear student, you must explain these steps, how you have drawn a Gantt chart and how you have calculated a waiting time of P4. So waiting time of P4 is equal to its turnaround time minus its arrival time. Turnaround time 0 minus 0. So waiting time of P4 is 0. Then P3 turnaround time 3 minus arrival time 1. So 3 minus 1 2. For P1 11 minus arrival 2. Okay, for P5 17, because it started on the 17 minus arrival time 4, and last for P1 it starts on the 21 milliseconds minus arrival is 5, so that is 11 minus 5. How you have prepared a Gantt chart? Who comes first? For 0 it comes P4, so P4 will assign the CPU. How much time it required for the P4? So it is a burst time. Depending upon the burst time, we have calculated a Gantt chart. So P4 it requires 3, so 0 to 3 P4, 3 to next 8 milliseconds P3, so 3 plus 8 11. At the 11 millisecond P1 will arise, 11 plus 6 17. At the 17 millisecond next process arrival, that is a P5, 17 plus 4 21. At the end P2, 21 plus 3 24. Okay, so you must have this priority of arrival depending upon the arrival time. So P4 has the first chance, then P3, then P1, P5 and P2. Then you can calculate a waiting time of individual process, then sum of the waiting time divided by number of processes, it will give you a average waiting time. My dear students, we can take the same example for all the algorithms. Then you can easily identify the difference between the algorithms. Okay, so this single example will be used in the different algorithms. Okay, so what is the advantages of first come first scheduling? So it is very easy to implement. It is the simplest algorithm. The algorithm is non-preemptive. Which process comes first will get served first. So disadvantages of this process is first disadvantage is non-preemptive. Due to that, a small process, that is a P2 requires only 2 milliseconds for execution, but it arrives at the 5 milliseconds, so it waits. Okay, so unwantedly waiting time of small process get increased. So average waiting time is very high. The shortest processes which require CPU for minimum time will be in the waiting. It is not ideal technique for time sharing operating system. It is simple but not very efficient. Okay, so these are some disadvantages of FCFS, first come first serve scheduling. Okay, so my dear students, we have started the algorithm, and very simple algorithm, first come first serve. Okay, so also we can take one simple example. Okay, so before going to end, we can take a simple example, P1, P2 and P3. Okay, we have only 3 processes, and its burst time that it requires for the execution. P1 requires 4 milliseconds, it requires 3 milliseconds, it requires 2 milliseconds. So its arrival time, so arrival time is like P1 arrives at 0, P2 arrives at 1, it may be arrives at 2, okay, and P3 will arrive at 1 millisecond. So what is the sequence in the first come first serve? So it must be P1 first, then P3 and then P2. So how to draw a Gantt chart? So Gantt chart is very easy. So starting of Gantt chart is 0, ending must be 7 plus 3, 4 plus 3 7, 7 plus 2 9. So Gantt chart last number is 9. Okay, so which process comes first? First is P1. At 0 is come, it requires 4. So P1 start from the 0 and ends on the 4 millisecond. Okay, next which process comes? P3. P3 will start from the 4 and it will end on the 4 plus 2 6. And last process P2 will comes at the 6 and it will utilize for 3, so it will be ends on the 9. So how to calculate a waiting time of P1? So P1 waiting time is equal to turnaround time minus average time. So what is the turnaround time? Okay, when it started 0, arrival 0, so it is a waiting time is 0 millisecond. For P2 for P3 P3 turnaround time 4 minus arrival 1, so it is a 3. Last for P2, it started at 6, arrival 2, so it requires 4. Okay, so sum of these waiting times are 7. Number of processes 7 divided by 3, so it will be 2.33 milliseconds. It is the average waiting time. So you can take a simple example and you can demonstrate the FCFS algorithm. It is very simple algorithm. You can take any problem and you can solve using the FCFS. It is a non-preemptive algorithm. Okay, so my dear students, you can solve multiple problems using the FCFS which are available on your net. So you can have FCFS problems and you can solve the multiple problems. Then your concepts are very easy to clear. Okay, in next video lecture we are going to start shortest job first algorithm, which having the two variants, preemptive as well as non-preemptive. Okay, still then, stay at home, stay safe, stay healthy, happy learning.